Hello students, my name is Urja Tiwari and this is our channel Ask You. Students, in today's lecture we'll study gravitation, which is one of the very important and one of the very interesting topic in physics. Okay, as soon as you hear the word gravitation, what comes to your mind? One of the very interesting story pops in our mind. That is the story of Sir Isaac Newton. You must have heard about this story because it's a really famous story. Once what happened, Sir Isaac Newton was sitting under an apple tree and he was studying something. Okay, he's a scientist, so we believe that he might be studying something. Okay, so an apple fell on him. So instead of eating that apple, he wondered why this apple is being attracted towards the ground, or is coming towards the center of the earth. Why isn't it moving upwards? Why isn't it moving sideways or in any other direction? Why is it coming towards the center of the earth, or is being attracted towards the ground? Right? He wondered why all the objects are being attracted towards the ground. So the answer to this question lies in this chapter. Okay, let me ask you one more question. Okay, assume that you and your friends or you and your classmates are sitting in your classroom and your teacher isn't around. What will happen? Some of you might be fighting, some of you might be chit-chatting, some of you might be gossiping about your teacher, some of you might be drawing something on the board, right? But as soon as the teacher enters the classroom or is about to enter the classroom, what happens? All of you will sit on your respective places and try to study something, right? So what we have learned, for governing students, the force of teacher is necessary, right? So in the same way, if we talk about our solar system, sun is placed in the center and all the planets are revolving in certain orbits or in certain paths around it, right? So for making those planets to revolve in that particular path, there must be some governing force. Which is that governing force? That is the force of gravitation. Okay, that is the force of gravitation. Let me ask you one more question. We have learned in the fourth chapter that if there is some motion, there must be a force, right? If a football is placed on the ground, it will not move on its own unless someone comes and kicks the ball, right? So if the pen is falling on the ground, if this pen is falling on the ground, there might be some force, there might be some governing force behind it, because if motion is being happened, there must be some force. So which is this force? This force is the force of gravitation. Okay, which is this force? This is the gravitational force. Okay, so let's learn the universal law of gravitation. Okay, universal law of gravitation says if there are two objects, suppose there are two objects placed at a distance d. Okay, when we take the distance, we don't take the distance like this. Okay, we take the distance in this manner, which is center to center. We take the distance to be from center to center. Okay, suppose the mass of this object is m1 and the mass of this object is m2. Okay, these are the two objects of mass m1, of masses m1 and m2, placed at a distance d. So what does universal law of gravity tell us? It tells that the force of attraction between these two objects is directly proportional to their masses and is inversely proportional to the square of the distance between them. The first statement says that it is directly proportional to the product of their masses, and secondly, it is inversely proportional to the distance, to the square of the distance between them. Okay, if we try to combine these equations, what do we get? We get F is directly proportional to m1 m2 upon d square. Now, if you look towards this equation, there is the sign of this proportionality. Okay, if we want to remove the proportionality sign, if we want here that the equation must include equal to sign, then we will have to add some constant. Okay, that constant is called capital G, which is the universal gravitational constant. Okay, this capital G symbolizes universal gravitational constant. Its value is G equals 6.67 into 10 raised to the power minus 11. Okay, the value of G is 6.67 into 10 raised to minus 11. But what about its unit? Okay, how can you calculate the unit? If we look towards this equation, what do we get? Okay, if I place G towards this side and F D square, this D square, if we shift it to this side, it goes in multiplication, FD square. And this M1, M2, if we shift towards the opposite side of the equal to, it will go in division. Okay, the unit of force is Newton, right? So this will be Newton, and D is distance. Distance is measured in meter, and there is square. So we'll write M square, Newton meter square. M1 and M2 are masses. Masses are always measured in kilogram. So this will be kg square. So the unit of this capital G is Newton meter square upon kg square. Okay, so this is the universal law of gravitation. Hope you have understood it.